1.1, day number 1 of AP Calc. We're going to talk about the following objectives: functions using equations, tables, and graphs, domain and range, composite functions, or compositions of functions, and then some notation stuff. Vocabulary terms here you can see: boundary points, closed intervals, open intervals, domain and range. Let's first start off by identifying the domain and range of the function f of x equals 1 over x. You may recall that the graph of f of x equals 1 over x looks like this. So our domain and range, domain has to do with your x values, and your range has to do with your y values. One way that you could write the domain here, as you'll see, you can see there's a vertical asymptote here at x equals 0. X can't equal 0, otherwise our function would be undefined. Therefore, our domain could be written in the following way. Two different ways, really. You could write it in this, this notation here, where x cannot end up equaling 0. That we would call interval notation, and then set builder notation, which would take on this form. Depending on the situation, either of those notations would be fine. Our range in the following function, of course, there's a horizontal asymptote there where y equals 0. Our function would never equal 0, so you'd see a duplicate here, either of our interval notation or set builder, except with set builder here we'd say all y such that y cannot equal 0. Okay, so in example 2, what you're going to see is a function square root of 4 minus x squared quantity there. This, if you're not familiar, is the top half of a circle, okay, of radius 2. Radius of 2. Okay, so when we talk domain, I'm just going to go with interval notation here. I would say -2 to 2, including both of those values. That would be a closed interval. And our range would go from 0 to +2. So you could see the range of possible values vary from there to there. And our domain of possible values could be any value between -2 and 2. So what are the conditions on the limit of the domain? Meaning, how is the domain limited? There's two different scenarios where that happens. One is if you have a radical, an even radical, like a square root or a 4th root or an 8th root or a 6th root, any even radical, this number right here. Right, typically you don't see it because it's a 2 and it's implied that it's a square root. Whatever we have inside that radical must be greater than or equal to 0. Okay, like we saw above. Right, so you could see that 4 minus x squared had to be greater than or equal to 0. Okay, which if you solve that, you'd see plus or minus 2 come out of that. The other thing is if you have a rational function, you have your numerator on top and you have your denominator on the bottom, that denominator cannot equal 0. Or if it did equal 0, then you'd be dividing by 0, which, of course, is not okay. All right, so let's move on to example 3. We've got f of x equals -3x squared, so f of -6 would be -3x squared with a -6 as its input. So if I were to simplify this, -6 squared is 36, and -3 times 36 is -108. So f of -6 equals -108. Okay, f of a plus 8, we're going to take -3x squared, and now in for x is going a plus 8. Don't be the individual that forgets that this is foiling in action. So if I foiled, this is a plus 8 times a plus 8, which we would get -3 times a squared plus 16a plus 64. And then we'd go ahead and distribute, and we'd see we'd get -3a squared minus 48a minus 192. That would be f of a plus 8. Okay, let's move on to composite functions or compositions of functions. So a notation issue here that I'd like to clear up right away. These two things are exactly the same. Their notation means the same thing. All right, so f of g of x means we're going to plug g of x into f of x. G of f of x means we're going to plug f of x into g of x. So if we know that g of x equals x squared and f of x equals x minus 7, then let's find f of g of x. So f of g of x. Let's figure out what that would be equal to. Let's take the shell of f, right? I have x minus 7. And into that, I'm going to plug g of x. This isn't groundbreaking on this question here because it's just going to be a simplification. Sometimes there will be some kind of order of operations that will require you to do a bit more algebra, but in this case it's pretty nice. Now f of g of 2, right, in this case all we would do is we would plug 2 in for x, subtract 7, it looks like we'll get a negative 3. So f of g of 2 would be negative 3. All right, let's take this and look at graphical representation. So check it out. I got f of g of negative 4. So let's first figure out what g of negative 4 is. Well, g of negative 4 from the graph, I'm going to go over to negative 4 and down to that value. Well, g of negative 4 is negative 4. So I'll be taking f of negative 4. This negative 4, not that one, this one. All right, so f of negative 4, what is that? Let's go on over here, over to negative 4, up to f's output. It looks like f of g of negative 4 is 4. So f of g of negative 4 equals 4. All right, let's look at a table representation of composition of functions. Okay, so I'm going to go g of f of g of 4. I'd be asking where'd the f of whatever go. Well, you'll see in a moment. Okay, so let's find g of 4. And I'm just going to do it this way. Let me go back. Okay, let's find g of 4. So let me prime this for a moment. All right, g of 4. What is g of 4? Looking at the table, g of 4 is 3. Okay, what is f of 3? F of 3 is 2. As I said, f of 3 is 2. What is g of 2? G of 2 is 2. So g of f of g of 4 equals 2. That's it for day number 1 of 1.1.